In the STM, we do have the universal synchronous and asynchronous receive transmitter ARTs. That's pretty much what we'll be using, particularly the number 2, because it's hooked up to the virtual COM port, so we don't have to mess around with additional wiring of the board. Here is so essentially what we have here is basically just connected it to the USB, and that's it. So this particular port establishes a virtual COM port that when we send data to it, the virtual port receives the data and we're able to see it. And how do we see it? In here, I really do like this serial port monitor. It's called CoolTerm. I will give you a link on where to download it. So if you're familiar with PuTTY, you will love this. So let's go ahead and get it configured. So for this particular one, it does automatically dictate what we have connected. So for example, if I disconnect this, so it's, if you notice, that disappeared. So it does dictate it, and if you notice, it has a virtual port as well. So let's go ahead and set it up. Let's set up the baud rate. You will see why I chose this port, and we'll just connect to it for now. Right now it has an old code that I have on the board right now. So if I hit a reset, it should, oh, that's the reset right there. So reset is always whenever I press reset, it just reboots the board and prints this. So we will create ours from scratch. So that's basically what we'll be working on right now. We'll go to CubeMX like we have always been doing for these STM32 projects. If you go back to my previous video, you could see that we have been diving into some STM32 embedded software development, and just follow along if you want to learn with me, because I am learning. So let's select the access to board selector. That will give us an opportunity to choose our board. So I'm just going to search it. So usually search it with RE, and that's this board right here, which is what the board that I just showed you. Initialize to default, that's fine. And when you start playing with art, so right now we have a lot of pins initialized. What I usually do is clear all the pins, and I should start fresh here. So now I want to set up my clock. So I want to choose the external crystal clock. And anything else I need here? Parameter? I don't think so. So now that I know I'm using the external clock high speed, I can go to my clock here, select the high speed clock, resolve clock issue. Alright, and we can go back to the pinout, and so far let's go to system and enable the serial communication. So that enables the serial, and let's go ahead and select the ART number 2 that we want to use. Asynchronous communication is fine, and this is the configuration baud rate word length that we can use to set up our receiving serial setup. Now if we go to project, we can type in YouTube all capital is fine. And we can debug it with this. Our toolchain is the STM32Cube, and everything else looks good. Then we can go ahead and generate the code. All right, we can go ahead and open project, and we should be good to go. All right, so I think it's still coming. This is our old project. All right, we can go ahead and accept that, and right here, YouTube, and then we can open up the core, the source code, and we can open up this. Now we have the auto generated code. So far we have the auth setup, main loop, hardware initialization, system clock setup, GPIO init, auth init. So one thing that you need to know is this is a private member auth variable. So whenever you are calling the hauth2, you are calling this to send, transmit data or receive data. So let's go ahead and define something, buffer. So let's do uint 8 underscore t. Let's do a data buffer. Let's do hello from STM32 data. All right, so let's terminate that here, and it looks like int 8 underscore t data is equals to, here we go. All right, so now we can go ahead and transmit that to our serial port. So we can do how transmit. So we can go ahead and do transmit here, and this has some IntelliSense. So it already knows that we declared a private variable out here. So I will select that. You also know that I already declared a variable data. I'll select that. So for the size, since I do not want to manually calculate the size, I can just type in size of data. Then I should probably minus 1 that is typically added for a string. So there one is basically excluding the null terminator. Then I need to wait for about 1 second and terminate it. So now I can, well, let's wait till the hardware, since this is a basic program, we can do a blocking wait. Here we go, and we can delay. Then I can put like a 1 second delay there, and based on this we should be able to transmit this data every second. So this data is essentially hello from STM auth data. So we will see if this works. I think it should work. Let's build the project and make sure everything compiles. 0 error, that's what I like to hear. So let's go ahead and flash the board. Now let's open up this, clear. We should start seeing our new message. Ooh. Hello from, let's do hello STM. Let's try this and flash it. Oh, okay. Here we go. I need to set up the debug. What happened last time? It should display this message. Let's clear the message. Oh, here we go. Here we go. Yep. And I can go ahead and one thing, you can add a timestamp here and it should look a little better here. So load this, and I can also add a termination, a new line termination here. So if I build it again, all right, yep, so it's working really well. And this hasn't built yet, so let's go back here, clear, let's wait for it. There we go. I think this is actually the new code. So this finished. Yep, that's great. And I will continue to show what I've learned so far. This is really cool. I hope you're enjoying this as much as I am. All right, thank you. Bye bye.